Yes. So let me continue with the molecular orbital theory, which in short form is abbreviated as MOT. Now, you all know the definition of a molecule. A molecule is formed by the combination of two or more atoms, right? As you already know the definition of atomic orbital, how is it defined? An atomic orbital is the region in space around the nucleus of an atom where there is maximum probability of finding an electron. In the same way, we define a molecular orbital as the region in space encompassing the nuclei of all the bonded atoms. It covers all the bonded atoms in which probability of finding the electron is maximum. So this is the definition of a molecular orbital. Now there are certain salient features of a molecular orbital. The notes, before I continue with the explanation, I would like to make it clear that the entire notes has already been put up in the Google Classroom. Kindly go through there. Now, one or two important points of the salient features which you need to remember. Now, atomic orbitals of similar energy and proper orientation combine to form molecular orbitals. As many atomic orbitals combine, so many molecular orbitals are formed. Suppose if two atomic orbitals are combining, you will end with two molecular orbitals. And remember, one of the molecular orbital will be having lower energy, which is called as the bonding molecular orbital, BMO, whereas the other molecular orbital will be having higher energy, which will be called as anti-bonding molecular orbital. The bonding molecular orbital with lower energy fills first, and then the higher energy anti-bonding molecular orbitals are filled. And filling up of molecular orbitals is in accordance with the Hund's rule and Pauli's exclusion principle. So I hope that this concept is clear to you all. Now you should also know the definition of the electronic configuration of a molecule. You all know the electronic configuration of an atom, that is distribution of electrons into the atomic orbitals is called as electronic configuration of an atom. Similarly, the distribution of electrons among the molecular orbitals is called electronic configuration of the molecule. So coming to another definition, bond order. Bond order, if you look in the short form, bond order BO is represented as half of NB minus NA. NB stands for number of electrons in the bonding molecular orbital. NA stands for number of electrons in the anti-bonding molecular orbital. So it is defined as, if you look here, it is half of NB minus NA. Half half the difference between the number of electrons in the bonding molecular orbital NB and the number of electrons in the anti-bonding molecular orbital NA is called as bond order. Now let us apply these definitions and the salient features to some of the homonuclear diatomic molecules. I hope you all know the meaning of homonuclear diatomic molecules. Homonuclear, like nucleus, diatomic, two atoms. The simplest example taken to explain molecular orbital theory is the hydrogen molecule H2. Here also you need to consider the atomic orbital of one hydrogen atom in the form of energy level diagram. So hydrogen atom has atomic number 1, 1 electron in the 1s atomic orbital. In the formation of hydrogen molecule, we require two hydrogen atoms, one and the other one. Here also there is one electron in the 1s atomic orbital. As I said, as many atomic orbitals combine, so many molecular orbitals are formed. Two atomic orbitals are combining, you are getting two molecular orbitals. One with lower energy called as bonding molecular orbital, and the other with higher energy called as anti-bonding molecular orbital. So the bonding molecular orbitals are indicated by the symbol sigma and pi, whereas anti-bonding molecular orbitals are indicated by the symbol sigma star, pi star, etc. Now, you should consider the Aufbau and Pauli's principle. Now, how many electrons are there in all? Two electrons. So, these two electrons will move first to the lower energy sigma 1s orbital. Two electrons. So, both the electrons have occupied the bonding molecular orbital sigma 1s, whereas the other higher anti-bonding molecular orbital sigma star 1s has no electrons. So therefore you can write the electronic configuration of hydrogen molecule as sigma 1s2, as the sigma star 1s orbital is 0. Then regarding bond order, so the formula used is half of Nb minus Na. How many electrons are there in Nb? That is number of electrons in bonding molecular orbital 2. How many electrons are there in Na antibonding molecular orbital? 0. So it will be half of 2 minus 0, that is 2 minus 0 upon 2, which is 1. So you will have a single bond between the two hydrogen atoms. So there is a single bond between the two hydrogen atoms. Since the bond order is positive, remember, whenever the bond order is positive, the molecule will be stable. And in the molecular orbitals, if you look here for hydrogen, the electrons are paired. If the electrons are paired, the molecule will be diamagnetic. If the electrons are unpaired, the molecule will be paramagnetic. In this particular case, the molecule is diamagnetic because there are no unpaired electrons. So this is regarding hydrogen molecule. To make this concept still more clear, I will consider another example, that of lithium Li2, lithium molecule, so that this concept becomes much more easier for you all. So look to the atomic orbital of one lithium atom. It has two electrons in the 1s orbital, electronic configuration 1s2, 2s1. So this is one lithium atom. Similarly, there is the other lithium atom, two electrons in 1s and one electron in 2s. Just look to the formation of the molecular orbitals here. Two atomic orbitals combine to form two molecular orbitals. Similarly, two atomic orbitals combine to form two molecular orbitals. One will be lower energy sigma 1s2, higher energy sigma star 1s2. Similarly here, lower energy bonding sigma 2s2, higher energy anti-bonding sigma star 2s. So in all, here there are two electrons and the other one has two electrons, four electrons. Two of them will go to sigma 1s and the remaining two will go to sigma star 1s. Now coming to 2s, there are two electrons, both of which will go to sigma 2s2 and sigma star 2s remains 0. So how do you write the electronic configuration of Li2 molecule? It is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s0. Now if you calculate the bond order now, half of Nb minus Na. Number of electrons in the bonding molecular orbital, here 2 and here 2, totally 4 electrons. In the anti-bonding molecular orbitals, 2 electrons are there. So it is half of 4 minus 2. That is nothing but 1. Hence there is a single bond between two lithium atoms. Once again, if you look to the bond order, it is positive. Therefore, the molecule will be stable. And all electrons are paired. If you look here in the molecular orbital, all the electrons are paired. Therefore, the molecule will once again be diamagnetic. So this is regarding another homonuclear diatomic molecule, lithium molecule. So this is something about the concept of molecular orbital theory. And the last concept is about hydrogen bond. Now, this is a special type of a covalent bond. You need to know the definition and types. That is more than sufficient. If you look to water molecule here, if you take water, there are a number of water molecules. When hydrogen atom is covalently bonded to an electronegative atom, it can be either oxygen or nitrogen or fluorine. So here also hydrogen atom is covalently bonded to an electronegative atom. The nucleus of the hydrogen atom is exposed and the electron pair is shifted towards the more electronegative atom. Now this proton or hydrogen carries a small positive charge. It creates attractive force with the electronegative atom of the adjacent molecule. Just look here. So these are the dotted lines. Now this attractive force is indicated by the dotted lines, and this dotted lines is nothing but a hydrogen bond. So look to the definition here. The attractive force between hydrogen atom and an electronegative atom. It can be either oxygen, fluorine, nitrogen, etc. of another molecule, generally of the same substance, is called hydrogen bond. So water molecule is the best example to explain the hydrogen bonding. If you look there, this is the hydrogen bond between two water molecules adjacent. Now there are two types of hydrogen bonds. The first type is called as intermolecular hydrogen bond, and the second type is intramolecular hydrogen bond. Now let me take the example of hydrogen fluoride. So there are n number of molecules of hydrogen fluoride. Fluorine forming hydrogen bond with hydrogen atom of adjacent hydrogen fluoride molecule. So these dotted lines are indicating the hydrogen bond. Intermolecular hydrogen bond is formed between two different molecules of the same or different substances. So in between molecules is intermolecular hydrogen bond. Whereas coming to intramolecular hydrogen bond, intra means within. The term intra means within. This compound is called as orthonitrophenol. Nitro group OH. Here hydrogen atom of OH group forms hydrogen bond with oxygen of the nitro group within the same molecule. The other example is that of salicylaldehyde, or it is also called as orthohydroxy benzaldehyde. Here also hydrogen bond is being formed between hydrogen of hydroxy group and oxygen of the aldehydic functional group. In these two examples, you can see the intramolecular hydrogen bond. It is formed between hydrogen atom and electronegative atom like fluorine, oxygen and nitrogen within the same molecule. So this is regarding intramolecular hydrogen bond. So this completes the chapter chemical bonding and molecular structure. Thank you, students. Once again, I would like to remind you all that the entire notes has been put up in the Google Classroom. Kindly refer to the notes and you can write them down in your notebook. I hope the concept is clear to you all. I will end the class here. Thank you.